Students, welcome to Alpha C Learning Mathematics session number 77. Today we are going to discuss about parabola. In previous session we have discussed about conic and definition of conic, different kinds of new terms in conic, and now today we are going to discuss about the parabola. And now here students observe what is a parabola. Yesterday we observed when the constant ratio E equal to 1, then a conic definition, then we said the locus of all points is nothing but a parabola. But exactly what is the definition? The definition is nothing but the locus of point which moves in a plane such that its distance from a fixed point, and this fixed point we called as focus, is same as its perpendicular distance from a fixed line. Earlier only conic means what is the value we got? The ratio of distance, okay, the ratio of its distance from a fixed point to the ratio, to the value of perpendicular distance is always a constant. The ratio, whenever it is a constant, then we called it as actually a conic. And in that particular definition, SP divided by PM you got, and this value you got how much actually? E. Understand? And suppose this E value is exactly 1. If E value is exactly 1, then we can consider SP equal to E times PM, and thereby here SP equal to how much? Directly PM. Understand students? SP is just PM. Now SP is PM means what is the meaning here? The locus of point which moves such that here distance from a fixed point is same as which one here? Perpendicular distance from the point P onto its directrix. So both the values are here one and the same. Now whenever they ask just what is equation of conic, understand, just what is equation of conic when focus is given as some -1, 3 and directrix equation given as some 2x minus y plus 1 is 0. Okay, and eccentricity value they may give here 1, or they may give here 1/2, or they may give here some 3, like that they may give about eccentricity. If nothing is given about eccentricity value, we just put it as E, and thereby we can obtain here the equation as SP equal to E times PM. Okay, then we can observe here the distance formula here, and here the perpendicular distance formula, thereby you can obtain here equation of a conic which is in second degree both x and y, right? And suppose E given as here some 3, then we substitute here 3. That means here to find equation of conic, the necessary conditions in the beginning we can say here, one is a fixed point and the other one is a fixed line known as focus and directrix. So what is the main equation students to find equation of a conic? The main equation to find equation of conic is nothing but here SP divided by PM is equal to how much here? E. So using this value we can find equation of any kind of conic when focus is given and directrix equation is given. Now in parabola directly you can say here SP is equal to PM because E value we have observed it is nothing but 1. That's why here we say here SP equal to PM implies the locus of point P. Here it is representing a parabola. Understand? Now once you got this value here, how I can get the standard equation? Of course you know it is a second degree equation, but we want to find here some standard equation in parabola which will be useful to us in coming other concepts. Okay, so let us take students here standard equation of parabola. This one is here definition of parabola, and standard equation of parabola I want to prove now. And standard equation of parabola is nothing but y square is equal to 4ax, where a value always greater than 0. X and y are variables, x comma y is any point on the parabola. Okay, now we want to hear the proof. Suppose just 2-3 lines only. How you can prove this result? Standard equation of parabola, y square is 4ax when a value is positive, right? Now here always in the data what are our values? A fixed point is given and a fixed line is given. So let us choose here the fixed point as here focus S and the fixed line L as here directrix. And later we'll take here one perpendicular from focus onto the directrix. Okay, so now here suppose this one I am taking and this is our focus S, and suppose this is the directrix L. Understand, in the beginning we are having only these two, and now I am taking here a perpendicular from focus L onto the directrix. Okay, so this one is perpendicular from focus onto the directrix. Let us say this one is the Z. Okay, and now you got here S and Z. Z is nothing but foot of perpendicular from focus on directrix line. Now extra another point also I am taking here A, which is on the line joining S comma Z. In a particular way I am taking, so that SA equal to A equal to AZ. Okay, so this is the point A exactly. Here the two distances are exactly A and A. Now students, you observe what is the definition of actually parabola. SP is equal to PM. SP represents focus to which one here? Any point on the curve is same as from the same point to the directrix perpendicular distance. So here SA is nothing but focus to this is A, and these two are equal. Implies clearly you can say the point A is exactly on the conic, that is on the parabola. So this one is a brief here description before we are going to start the problem, that means the theorem proof. Now after this students, I want to take here this line joining S comma A comma Z as x-axis, and next one the line parallel to directrix, exactly it is nothing but y-axis, which is passing through moreover through A. Okay, which is passing through A. So this I want to take here y-axis. Then immediately A will become how much here? 0 comma 0. And what about S value here? A comma 0. And thereby this side you are getting, hence Z coordinates are minus A comma 0. Moreover, what is equation of here this directrix? It is nothing but a line parallel to y-axis. Therefore, I can write this equation as x plus A equal to 0 or x equal to minus A. Okay students, so till now you have got here focus as A comma 0, and this is our A point 0 0, and next one Z is here minus A comma 0. Moreover, A is a point on the parabola. Okay, now after this description, let me take a point P on any point. That means this is a locus point we are taking, suppose x1 comma y1. But how I have to choose this point such that SP must be same as how much here? PM. Okay, that means if I take the point here, suppose P of x1 comma y1, then SP value, whatever distance from S to P, it must be same as perpendicular distance from P onto which one here? Directrix. Okay, so this one is SP equal to PM. In such a way I have taken one of the points as x1 comma y1. Then according as the definition of parabola, okay, according as the definition of parabola students, we can take here SP is PM implies, so right here as P of x1 comma y1, understand, be any point on the parabola. Okay, now the conic we are writing as parabola, be any point on parabola. Therefore here what is our condition? SP equal to PM. Okay, SP is PM. Now you came to know about coordinates of S and you came to know about equation of directrix. Then I can substitute directly in all formulae. So that what is the value here? Under root of it is x1 minus A whole square plus this is here y1 square, and this is PM, perpendicular distance from x1 y1 onto the directrix, that is mod of x1 plus A and divided by 1. Now let us do squaring both the sides, thereby you will get here x1 minus A whole square plus y1 square equal to x1 plus A whole square. Okay, now take this value to this side and thereby y1 square equal to x1 plus A whole square minus x1 minus A whole square. Now this is of the form A plus B whole square minus A minus B whole square. Thereby you can write it as how much here? 4A x1. Now this is true for any point on the locus. what is the locus here? Wherever SP equal to PM is satisfying, it is true. Implies y1 square is 4ax1, y2 square is 4ax2, y3 square is 4ax3, etc. In general, for any point on the plane, wherever it is satisfying this condition, we can say the equation is nothing but y square equal to 4ax. So finally what we write, students, here, which is true for any point on the locus, hence equation of parabola in standard form is y square equal to 4ax. Understand? Which is true for any point on the parabola. Okay. Observe, students, just now we have completed the proof of parabola standard form, that is y square equal to 4ax. Okay, and while writing y square equal to 4ax, keep in mind a is always here positive. Okay, a is always positive. And now here, whenever we have taken the definition, that is focus is yes, and next this one is our directrix. Okay, and we have taken, suppose P is in here. Understand, one of the points on the locus, if you take here, then we have observed SP equal to PM for parabola. Again, if I take the point here, you can write here SP equal to PM as parabola. Like this here, you can write here even on the axis also, we can observe here. These are all points. Now, if I join all these points, you can get here a curve in this way. So, this is from our previous theorem proof. What is nothing but y square equal to 4ax for one point we have taken, and thereby we have generalized here for many points on the locus. Okay, wherever the point you consider on this curve, everywhere, every time you will get SP1, PM1. Understand, again SP2, P2M2, SP3, P3M3, etc. You will get every time the standard definition of our parabola, that is SP equal to PM. Okay, so now the curve will be of this form. Then let us observe here some whatever the new terms already we have introduced in the previous session. Here exactly values also. Okay, you know here first of all what is axis. Axis means actually it is a line passing through the focus and perpendicular to directrix. Okay, so axis is nothing but passing through focus and perpendicular to directrix. Now here to this standard parabola, what is that axis? So to this standard parabola, the axis is here nothing but x-axis. Okay, and next one to this standard parabola, so equation of axis we can say here it is nothing but how much is y equal to 0, because x-axis equation is y is 0. And next one, the next observation, focus coordinates, how much you got here? A comma 0, because we have chosen SA equal to AZ equal to how much here? A. So this value we have chosen, thereby you got SA is AZ is small a implies, and this one is exactly our y-axis x-axis intersection origin. Therefore this is nothing but a comma 0. Therefore what about here? Focus coordinates a comma 0. That is only for this kind of standard form. And next one, what about here? The equation of directrix. The equation of directrix you observe, it is x plus a equal to 0, because this is a line parallel to y-axis here and passing through minus a comma 0. Thereby the equation of directrix is x plus a is 0. And next the other one is nothing but this is tangent at the vertex. So how is a tangent at vertex? What is the definition of tangent at vertex? The tangent drawn exactly at the vertex. And what is vertex actually? The point of intersection of curve and axis. So if this is the conic curve, parabola curve, and this is the axis, then this is our point of intersection, which is known as vertex. And here the vertex is nothing but exactly origin. And next one, this is y-axis here seems to be, but what is according as the definition, students? It is nothing but tangent at the vertex. So tangent is drawn at the vertex, and this is our tangent at vertex. And next one, you observe this is one of the chords you can observe. And how is this chord? It is seems to be like double ordinate as well as here focal chord. The combination is nothing but here latus rectum. So how is this latus rectum? It is exactly parallel to y-axis and passing through focus. Therefore what is equation of latus rectum here? It is x is equal to a. That means x minus a equal to 0 is equation of latus rectum. And what about here the length of latus rectum? At the same time, what are end points of here latus rectum? How to find here end points of latus rectum? Suppose if I take here one of the points as on this one, y square is 4ax, isn't it? The curve is y square is 4ax. And observe here the latus rectum definition itself is a double ordinate. Double ordinate means here it has to be perpendicular to axis. Now again it is passing through focus. Therefore observe what is this length. This length is nothing but how much, students? It is a. Okay, as this length is a, therefore here also if you take this length is how much here? A. Therefore we can take here x coordinate as a. Now at present I don't know about this value. Suppose I am taking it as k, right? And this one is here, this is passing through focus and perpendicular to axis. So clearly you can say SA equal to small a. As SA is small a, so this value also here a. And now our interest is to find value of k. So where is that a comma k point? This point is lying on parabola y square equal to 4ax, right? And therefore k square equal to how much here? 4a square. Hence k equal to how much here? Plus or minus 2a. Therefore as a is positive, so I am taking here how much? A comma 2a, followed by this point is nothing but how much? A comma minus 2a. Finally, what is length of latus rectum? The length of latus rectum is nothing but here 4a. Okay. So students, these are all our observations from the standard parabola. So in standard parabola, you can observe here points like that. First one is focus coordinates a comma 0, and next one is directrix equation x plus a equal to 0, and next here vertex 0 0. Tangent at vertex equation is, it is y axis, therefore the equation is x equal to 0, and next one it is equation of axis y is 0. So in this way we can observe here different points with respect to standard parabola y square equal to 4ax. Okay. Now let me take here a small example. Suppose the problem is given as y square equal to 8x. Okay, y square equal to 8x. They will ask about here find all kinds of values. First one, suppose vertex. Okay, first one is vertex. Second one if it is focus. Okay, and next one it is here the latus rectum coordinates as well as the length, whatever regarding latus rectum. And next one if they ask about here equation of directrix and equation of here tangent at vertex also. Okay, so if they ask about all these points, then how to find? Now just we compare the standard equation with the parabola, that is y square is 4ax and this is y square equal to 8x. Thereby you can find here what are the values. 4a equal to how much? 8, and hence a value is how much here? 2, right? A equal to 2. Now what about to this standard form vertex? It is nothing but 0 0. And what about here focus coordinates? Focus to this standard form, the formula is a comma 0, hence here it is nothing but 2 comma 0. And what about here length of latus rectum? Length of latus rectum is 4a, and here it is 4 into 2, thereby it is 8. Okay, that is exactly the coefficient of x you can take. And next one, what about equation? Equation of latus rectum. How it is actually? It is nothing but x value is equal to a. So a is 2, therefore the equation is x equal to 2. Next one, what is equation of directrix? And directrix is nothing but here x plus a is 0 implies x plus 2 equal to 0. Now tangent at vertex, it is nothing but a line here, that is y axis here, and therefore here it is nothing but x is 0. Like this here we can use the standard form y square equal to 4ax. Okay students, just a small example I have taken. And now what are still other observations from the curve? Okay, what are still other observations from the curve? Now if a greater than 0, observe here x value and y value. Other kind of observations apart from these coordinates. Okay, the observations are, students, here if I write as x is very large. Okay, when x is very large, then what about here y values? Understand? Y square is tending to here infinity. x is very large. If you increase here correspondingly x values like this, then y also going to be what here? Large. So whenever you draw parabola, don't draw in this way. You have to draw the parabola like this. That means the values can go to here plus infinity as well as here minus infinity. So you cannot draw parabola in this way. Of course, in a hurry we used to draw like this, but the actual thing is here, as x is tending to infinity, x is taking very large, y also tending to here largest values, moreover positive large as well as negative. That means y tending to here what here? Plus or minus infinity. Okay, this is one of the observations. That means no end to this graph. It goes up to plus infinity and here minus infinity when x values are too large, right? So this is one of the observations. And next, the other observation, students, you have to consider here y square is there. Understand? That means this is even par. Once this is even par and it is here 4ax you are having, that means y square value must be always positive, as a already we have decided positive. So y square value it is 4a and this is positive, this is positive. Therefore, this x necessarily must be what here? Positive, so as to make y square value as positive. That's why here you observe the curve is taking part only this side. Understand? The curve is not taking any part on the negative side of x-axis. So the curve is occupying completely the positive side of x-axis only, because this side you are having here even par, right? So y square is 4ax, positive, positive, a value every time positive, because it is indicating the distance between s and a. And therefore, to make this value as positive, the x necessarily here positive. Understand all of you? So here, that's why we can say x value always positive, hence portion of the curve is completely towards positive side of x-axis. So what is the next observation, students, here? As y square greater than 0 or equal to at this stage exactly, implies x value must be here greater than or equal to 0, since a value already here positive. Understand? And next observation, see here we have taken this one as exactly double ordinate. Okay, whatever the values, that means here if I draw like this, again if I draw in this way, if it is 2a, a comma 2a, immediately I can say a comma minus 2a. Because of what nature here? The nature is just because the curve is symmetric about x-axis, or symmetric about, you can say, axis of that parabola. Okay, so here in this particular standard form it is symmetric about x-axis, because of the reason whatever values you are getting above x-axis, same values for y you will get even below x-axis also. Okay, now that means here if I am taking, this is the point a comma, just now we observed while taking here the lattice rectum or some other point also, if I take x1 y1, then what is the nature here? y1 square equal to how much? 4a x1. Then what is y1 here? Plus or minus 2 root a root x1. Okay, so plus or minus implies here if I got plus 2 root a root x1, here immediately you will get minus 2 root a root x1. Understand here? So plus or minus implies here the curve is exactly symmetric about which one? Axis of parabola. Therefore the other point is nothing but curve is symmetric about axis of parabola. Understand? So students, till now we have observed different terms in the standard parabola, y square equal to 4ax. Okay, and so we have observed length of lattice rectum as 4a and end points of lattice rectum as a comma 2a and a comma minus 2a. Okay, and one more definition also there, that is nothing but focal distance. Okay, to the standard parabola, y square is 4ax. What is the focal distance? The focal distance is nothing but, what is the definition? Distance from focus to any point on the parabola. Okay, distance from focus to any point on parabola is nothing but here focal distance. Suppose let me take here one of the points as this is x1 comma y1, which is any point on the standard parabola, and this equation is y square is 4ax. Okay, now here suppose the point is x1, y1. I want to find now here what is the focal distance. Now to find focal distance, students, here what is our formula? SP. This distance we require, and if I use distance formula x1 minus a whole square and plus this is y1 square if I take the square value. Okay, and now this is nothing but here y1, x1 y1 is nothing but a point on the standard parabola, implies it has to satisfy this equation. That implies y1 square equal to how much here? 4ax1. Therefore I am writing here x1 minus a whole square plus 4ax1, thereby a minus b whole square plus 4ab formula, and thereby this is nothing but x1 plus a whole square, and hence SP value. What is SP value here? It is mod of x1 plus a. Understand? So this is the formula for SP, because of it is a distance, and thereby we can say mod of x1 plus a, focal distance to this standard form. So whatever formula now I am writing, those are here meant for the standard form y square equal to 4ax. So focal distance to the standard form is x1 plus a, where x1 comma y1 be any point on the curve. That means abscissa of P is here x1. Okay, a means the standard value, that is distance between SA. Understand? And next one is, students, here you observe whenever a problem is given y square equal to suppose 4x is given. Understand, y square is 4x. They ask about find here the focal distance of the point. That means here SP value they ask. That depend on here abscissa of given point. Understand, P of suppose take a point which is satisfying the equation 1 comma 2 I am taking. 1 comma 2 if I take 4 into 1 is here 2 square, that is 4. Therefore this formula is nothing but here it is mod of 1 plus. What is our a value here? 4a equal to 4 implies a equal to 1. So this is here 1. So how much you got here? SP value 2. Instead of finding here distance formula from focus and P, directly you can make use of the result in this way. Got it all of you? And next one is here the other form of parabola. Not only this form, students, the other form also there. We have different forms of parabola are there. At present we have taken y square is 4ax like this. Understand, in this way. And next the other form I can say here, this is the other form. Understand? And next one I can take in this way also. So here I am taking this one as here our axis, and the other one is downwards. So one is here open towards here left side, that is right side, and open towards left side, and the other one is upper one and the other one is lower one. Understand? Where everywhere we are using coordinate axis, x axis, y axis as our here axis of parabola. Sometime I am taking here x axis as axis, and for upper one, lower one we can choose as y axis. Understand? So now suppose we observe this kind of parabola. Y square equal to how much here? 4ax actually standard form, but just I have taken the curve this side. Understand? Once I have taken curve this side, this is nothing but minus 4ax, students. Always minus 4ax means a is not negative. Don't understand it is 4 into minus a into x. This is wrong. Okay. So it is minus 4ax means a must be here greater than 0. Okay. Once you got the value in this way, therefore what about the nature of the curve? Again, as usual, you observe y square seems to be negative, but y square always must be positive. So as y square always positive for real, therefore a is here positive, 4 is here, implies x values must be here negative, right? So x must be negative. So all our x values, they must be negative. That's why we have taken the curve completely towards what here? Negative side of x axis. Okay. So this is completely towards negative side of x axis. The curve is coming in this way. So treat here a always positive, y square must be positive, implies x must be negative, hence the curve is in this way. Now this entire value is here positive. So y square positive, just like however we have discussed in the previous one, as x is tending to minus infinity, y value tending to here plus infinity, minus infinity. Understand? So again it is symmetric about here x axis. Whatever the portion of the curve above x axis, same you can observe even below x axis also. So again, what about different coordinates? And as here a you are representing, just only minus symbol is there, that implies here focus is nothing but minus a comma 0. This is our focus coordinates. And next one, lattice rectum, here this distance is minus a, therefore it is minus a, and 2a plus or minus we can write. And therefore ends of lattice rectum are nothing but how much here? It is minus a comma 2a, minus a comma minus 2a. Of course length is nothing but how much here? It is 4a. Okay, length of lattice rectum length 4a as it is. And next one is here equation of directrix. So directrix is falling exactly this side. So what is directrix here? It is x equal to a. So this is our directrix equation followed by lattice rectum equation. How it is coming here? X is equal to minus a. Understand? And this one is our tangent at the vertex, that is nothing but x equal to 0. Got students all this? Now the same values whatever you wrote in the previous one, just we replaced a by here minus a. Understand? We replace wherever a is there, just we replaced by minus a. So first one is here vertex as it is, here no a, as it is 0 0. And next one directrix equation. What is this value? X value equal to how much you got? A. Understand? X is a. And next one tangent at vertex. So tangent at vertex, how much you got here? It is x equal, this is here y axis, therefore x equal to 0. And next one focus yes. What is focus yes here? It is minus a comma 0. And next one here as usual length of lattice rectum remains same, that is 4a. Understand? And ends of lattice rectum are minus a comma plus or minus 2a. So these are some descriptions which we have observed from this y square is minus 4ax, right?